Hey, what up, fam? This is Saul Levy, host of Africans in Tech, where we're building bridges and shaping futures in tech. On our episode today, we got Abdi Mohamed. Abdi's going to talk about architecting AWS. I know for some of you have seen some of the AWS stuff that we've talked about in the past, but I think this episode is going to be dope because Abdi's going to get really deep into what it's like to build, different types of applications in AWS. So it's a dope episode. So Abdi, on to you, bro. Let's kick it.
All right, let's get it. So first off, again, folks, my name is Abdi Mohamed. Today I'm going to talk about, building out an architecture diagram for the cloud. So folks, when you hear cloud, understand it boils down to IT. It's just IT, but the way you access the IT is different, right? The difference between on-prem IT versus cloud IT is cloud is IT that you access over the internet using a pay-as-you-go pricing model. Again, cloud is access to IT using a pay-as-you-go pricing model. Okay, and there's different cloud service providers. I'm more of an AWS guy, so that's what we're gonna do. We're gonna do AWS. All right, so we got a 3-tier application. Whenever you have an application, right, it boils down to compute, networking, and storage. That's the formula. Whether you were building an app 30 years ago or you're building an app today, you're building an app 30 years from now. You need compute, networking, and storage, and that's what we're gonna do right now. So first off, right, imagine we're working in a corporate environment, right, and we have the internet, right? A little cloud. We're gonna call this beautiful cloud the internet. All right? Internet. All right, this is the internet, right? Now, we have your corporate intranet, right? Your corporate intranet, right? Got a little machine. You're working in a big corporation, right? You got your big corporate intranet here. All right? And now you have your corporate firewall, right? So it's going to do a big firewall.
Okay. Quick question. So intranet versus internet. Can you talk a little bit about that?
Yeah. So intranet is a corporate internal network, right? Meaning only folks who are within the corporate bounds, right, get access to this corporate internet. So this is not open for the public, whereas the internet is open to the whole public. Everybody can access the internet. Right? And again, intranet is an internal network for the business itself, right? Make sense?
Yep, perfect.
Cool. Then you have the corporate firewall, right? So any traffic from the internet has to go through the corporate firewall. Any traffic from the internet has to go through the firewall, right? And now from the firewall, okay, you have a large VPC here, AWS VPC, okay? Virtual private cloud. So VPC is a virtual private cloud. All right, and to get access from the corporate intranet through the firewall to the VPC, you need this service called Direct Connect. Direct Connect is a service for DN. It's a service that allows you to connect from your corporate network to AWS, right? So you have your Direct Connect service. All the traffic is going through the firewall, and the first stop of the firewall, the traffic that goes to the firewall is through a load balancer, right? So load balancer, we're going to call this LB. LB, yeah. So load balancer is it's really just a server. Its job is to guide traffic, okay? And again, we're in a VPC inside AWS, right? You have a load balancer. Excuse the legibility, all right? And now, the load balancer guides traffic. We got to set up availability zones, so we're going to call this AZ1. AZ2, and I'll explain availability zones in just a bit, okay? So you have 2 availability zones, you have your load balancer, right? And now the traffic is being guided, to your instances, right? So an instance is a virtual machine, again, it's a server, right? For your web application. We're setting up a web application, 3-tier web application. It can be any type of web application. In this case, we'll go .NET, right? .NET, 3-tier web application. So you have EC2, and then we have an EC2 here, okay. So the reason why we have 2 EC2 here, right, is because, when you have a web application, right, when you're leveraging AWS, if one server goes down, right, the load balancer can then guide the traffic to this other EC2 that you see here. That's one of the benefits of using cloud, okay? You have the ability to scale up and scale down based off of demand. If you're having a lot of traffic or this availability zone goes down, well, guess what? The traffic falls over to this EC2 that you see here. Okay? And the reason why we're able to do this is through auto scaling. So it's going to be called auto scaling. I'm just going to say A.S. This is auto scaling. This allows you to scale up, your instances. Maybe you want to, vertically or horizontally scale. What we see here is a horizontal scale. So the difference between a vertical scale, in cloud versus horizontal scale is that vertical scale is saying, hey, I have a small server. I want to make this a large server, right? So you're increasing the underlying hardware. But here, this is a horizontal scaling, meaning we replicate what we already have. I already have a small server here. Okay, I want to replicate that to the second server here using auto scaling groups. Now, if we want to get a little bit more granular, right? If I want to ensure that this server is the exact same server that you see here, we have to use this thing called a launch template. And pretty much it's instructions that guide the auto scaling group on what you want your instance to look like. All right, and in our launch template, we're going to define it using the instructions that we have on this EC2 here, using auto scaling groups. All right, so now we have the the web tier. Now we need storage. We got to have storage, right? We got to store our data somewhere, right? So we have a SQL database using Amazon Aurora /RDS. So I'm going to put Aurora DB, right? And again, we're leveraging the cloud, right? So we're going to have Aurora DB, replicated across availability zones, right? So availability zones, Aurora DB. Okay, you have your database. You're storing, you have a SQL database. You're storing your data in the SQL database, right? And also you have S3 here. You have S3 for your object storage. So S3 is a service you can use in AWS to store objects. You can store files. You can store PDFs, whatever you want. You can store those type of objects, right? So S3, right? This is where we're going to store our code, okay? And S3 in our object storage. And we're going to deploy our code using AWS Code Deploy. So Code Deploy is a service in AWS that you can use to deploy your application code, right? So, looking at this, right, I know there's a lot going on, right? So let me guide y'all through what's going on here, okay? You're in a corporate network, right? And you want to have a 3-tier based web application, right? All the traffic goes through your corporate firewall, right? We want to make sure that we're inspecting all the traffic that's going through here, right? And what you see here, this traffic is, it's encrypted under port 443 using SSL/TLS certificates, right? So if you have a web application, you want to make sure you're encrypting your data in transit. This supports confidentiality, right? This encryption, you use the SSL/TLS certificate for your encryption in transit. Now in AWS, if you want to, manage your certificates, you can actually store your certificates in the service called Amazon Certificate Manager, okay? So you're guiding the traffic, it goes through your load balancer. Again, it has to go through the load balancer because, well, it doesn't have to. You don't need to have a load balancer, but it's strongly recommended to use a load balancer because it's a dedicated server that allows you to guide your traffic where you want to go, right? So this availability zone that you see here, we're going to call this AZ1, this availability zone right here. If this availability zone goes down, God forbid, well, guess what? Now the traffic, it can fall over to this availability zone that you see here, AZ2. Right? This traffic, this availability zone that you see here, okay? This is what we call a highly available application. Now, there are many ways to skin the cat, many ways to architect an application in the cloud. This is a basic 3-tier web application that allows you to leverage the cloud. Okay, so if you're going to go in the cloud, make sure you're leveraging auto scaling. Okay, we talked about encryption, right? Encrypting the traffic, using port 443, using SSL/TLS certificates, right?
Yep.
Now let's talk about costs. Right, we addressed some of the security risk. Well, I'll talk about one more thing in terms of security. When it comes to AWS, you want to make sure you're implementing the principle of least privilege. So whoever has access to this AWS account, you got to make sure that they are people who are trustworthy, right? That are within your organization. And on top of that, make sure you're following the principle of least privilege, right? What that means is that whoever's using this account, who's using this architecture, they're only using for what they need, right? That's all they get. You'll only get access to what you need. Okay, so that's a little bit of security. Now, let's talk about the costs. So, you can scale up to 4 instances, 4 EC2s, 5 EC2s, quite a few EC2s, depending on the traffic, right? But you got to make sure that, when you're in AWS, you have to be mindful of the costs that you're using. Whatever technology that you're using, you got to be mindful of the costs. One of the ways you can mitigate some of the cost risks here is by only scaling up during certain periods of the day, right? That's what we call scheduled scaling, okay? You can also schedule a downtime for your instances. For example, you can schedule your servers to have one instance, in certain periods of time, and during certain periods of time, like let's just say from 9 to 5, right? Okay, we'll scale up to 2 for our production application, right? Because that's when the core work hours are, and that's when our customers are going to need our application during those core hours. Let's scale up to 2 instances at that time, right? You can do that. What you can also do is schedule downtime. Saying, hey, after 6 p.m. EST, we don't want our servers on anymore. Let's schedule a downtime so you can terminate your servers. Terminate, as in delete, get rid of them, right? That allows you to not only save costs, right, but it also saves you some headache, right? With managing servers, in AWS. Okay.
Nice.
So yeah, that's some of the costs that you can mitigate here. Scheduling downtime, also picking the server type. So in AWS, there's a lot of different instances that you can pick, right? Depending on what your use case is. Some folks might pick a memory optimized instance. Some folks may pick, a high performance compute type of instance. Some people pick general purpose. Be mindful of the processors that you're using. In AWS, you can actually pick, an EC2 instance that's really good in terms of cost efficiency as well, called AMD. AMD is a processor that you can use in AWS that can give you an additional about 10% discount, Also, you can look at the Graviton powered instances as well. Those are even more cheaper. Again, check with your management, check with your people, check with your business. But yeah, I would say, picking the right instance type is important because AWS has a lot of different instances that you can choose from for your web application. You just want to make sure that you're picking the right one given your use case. Again, if you want to address costs with EC2, schedule downtime, okay? Also, leverage auto scaling that we're using here. We're leveraging auto scaling. And lastly, pick the right instance type. If you're going to be using something like a basic EC2 instance that is general purpose, like an Intel processor, pick AMD instead or Graviton. Much cheaper and much more efficient.
Nice. So let's recap a little bit. So you have your internet, your internet, you have your intranet. So people go through the firewall, and then your firewall connects to, maybe has a direct link to the VPC with Direct Connect, right? Can you explain a little bit about Direct Connect for people who don't know?
Yeah, so the reason why we have Direct Connect, right? Direct Connect is a service in AWS that allows you to connect from your corporate machine, right, to the VPC, to the resources in AWS. If you don't have Direct Connect, connecting from the corporate network to your VPC is borderline impossible. You won't be able to do that. So you need Direct Connect, to serve as that gateway to allow you to get access from your corporate network on your corporate machine to the resources in AWS.
Yeah. Okay, so that's good. So, we don't have to talk about like private links and all that other stuff, but like let's say like for instance, somebody. Okay, you get through your load balancer, and let's say you have an app that needs to be publicly available, not just to your internal users. You need your app to be publicly available to, let's say, you're building an app that needs to be available to, I don't know, the world. Mm-hmm. What are some options where you want to segment the traffic that's coming in from your internal versus traffic that's coming from your external? And let me know if that makes sense.
Yes, you want it to be a public-facing application?
Yes, you want to make a public-facing application.
Yep. Yeah. So I don't think in that scenario, right? Well, first we got to check what type of data we're working with.
Yep.
Before we launch anything to be public-facing, so we have to make sure we're not having any data we're not comfortable folks seeing.
Yep.
So any classified data or any IP. What do you call it? Yeah, IP. And check the data sensitivity data types first. Then, if you wanted to make it, in a sense, a public-facing application, then yeah, it would go straight from the internet, right? And then I don't think you would need your corporate firewall in that sense,
yep.
Right? It would be a public-facing application. You'd get out of the firewall,
yep.
But yeah, the application would be facing the internet.
Yep.
You would be you could monitor because it's a corporate application. You would still need to put some security guardrails in terms of like monitoring the application,
yep.
Right? Your Splunk, your CM, yep. You need that. AWS has like different services to monitor your application security as well. Yep. So you definitely need that as well. But yeah, I would say if you want public facing with this application, you still would need to. You probably would need the corporate firewall for it to go through because it's a public facing application.
Yep.
But you definitely want to make sure that you're not uploading any sensitive data. Number one, you're you're also being mindful of actually you don't have to. You could get rid of the firewall, but you could actually use AWS web application firewall, to monitor any traffic, any malicious traffic that might be coming in. Because if this website did go down, and it's a public facing website, it wouldn't be looking good on the company. So something like a web application firewall from AWS, that would make sense. That way, it can monitor the traffic, and in response to any like a DDoS, distributed denial of service attacks. So something like that, you would need that. But yeah, I would say having web application firewall from AWS, that would be good, for a public facing app, and also just make sure what type of data has been displayed on the app. I would also double check that as well.
That makes sense. The reason I was asking, because some folks may be watching like, all right, why do I need a firewall? Or why do I need a direct connection? Like, I can just go directly to AWS now. And there's like multiple ways you can do that. It depends on what you're building. Like you said, like this is an internal app. Like the initial build was for your internal customers. You're building something resource wise and all those things like should be only for your internal developers, team, whatever it is. Or you may have like another, private link or whatever it is set up where, you can give exposure to, another customer. You can maybe put that data in a DMZ or something like that and then have direct access that way. But in this case, we're building something internal just for customers to be able to do, or engineers, customers to be able to do what they need to do. And then your load balancer, we talked about it, where it goes to multiple instances behind, and then you have your ASGs, your groups behind it that get spun up as needed. With your load balancer, can you talk just slightly, and I don't want to get too deep, but let's say, how does a load balancer work in terms of like, let's say one whole AZ goes down, which never really happens, but let's say a whole AZ goes down. How would it work in terms of like now switching over to like the secondary a zone? So
availability. So how does, like, let's say this thing goes down. How does it go through this trap? I would say you'd have to configure that in AWS for your load balancer. You have to configure your it's not I can forget the name. It's like in your load balancer, your
active passive, whatever.
There we go. Active passive. So you got to pick which availability zone is going to be the active versus which one's going to be the passive. And that's going to be you go active if you want to. You go active.
So we go.
These are on. These are both at any given moment. These are both on at all times. We're ready to go. Right. But you have to configure that within your load balancer. And once you configure that, then you can allow when traffic is being guided, right? You can pick, okay, how do we want to do this? Right. There's different ways to guide traffic. There's like, I think there's like round robin.
Right? Weighted and all that.
Weighted. But I would say definitely, if you're going to be leveraging a load balancer and availability zones in AWS, double check your load balancer. How you're configuring that. Because there's different types of load balancers, right?
Definitely.
The load balancer that we're using here, we're using the application.
That's what I was about to say.
So that operates at layer 7 of the OSI model. Right. So if you study for Network Plus or understand network fundamentals, right? The OSI model, it's a model that allows us to understand what's going on across the networking sphere, so to speak. And so this load balancer is not a network load balancer; it's an application load balancer. The reason why we have an application load balancer is because it's using the HTTP protocol. HTTP, I believe, runs on layer 7. And so we need an application load balancer in this case. And there are use cases for network load balancers, I believe. You could use network load balancer for any like doing work with LDAP. You might want to use a network load balancer in that type of scenario. But in this case, we have an application load balancer. We have an application. We're running HTTP. We need an application load balancer in this case.
Perfect. All right. Well, Abdi, want to thank you very much, bro. You killed it again.
No, I appreciate it, man. This is nerve-wracking, man. This is not my greatest work, folks. I do much better work with PowerPoint. What's the other stuff new folks are using? Visio? Is that
Oh, yeah, Visio. Yeah,
Visio.
yeah.
It's much prettier in Visio, I promise.
No, this is good enough, bro. So, guys, if you want to get in touch with Abdi, can you give them how to get in touch with you again, man?
Yeah, if you want to get in touch with me, give me a holler at amohamed.elevate at Instagram. So Mohamed, A as an apple, MOHAMED.elevate on Instagram. And then I'm also on LinkedIn as well, Abdi Mohamed on LinkedIn. I'm also on YouTube as well. I don't post much on there, but I'm finding the courage to get on YouTube more. Okay? It's also at Abdi Mohamed. Shoot me a follow, like and subscribe. And shout out to Africans in Tech for having me. This was lit. I learned a lot. All right, Africans in Tech, baby. We're going global. Pull up. This is the vibes.
It's our ultimate hype, man. I really appreciate you for being on the pod.
This is good.
All right, guys. Well, thank you to Abdi again. If you missed how to get in touch with him, we'll have all his information at the bottom of wherever you're watching this at. And if you want to get in touch with us for whatever reason in regards to anything that Abdi said, or if you want to get in touch with him and maybe collaborate, you can hit us up at africansinTechnology@gmail.com. Again, it's africansinTechnology@gmail.com. My name is Sar Levy. This is Africans in Tech, where we're building bridges and shaping futures in tech. All right, fam.